Hello everyone, welcome to DevStandup episode 21. Today our guest speaker is Phani Turlapati. Phani is a product manager at Oracle. He's working at Oracle for almost 8.5 years. He started Oracle as a cloud solution engineer and then transitioned into product management. And prior to his experience in Oracle, he was a Java developer for CNSI and Cognizant. And today, Pani is going to talk about a topic named JSON Relational Duality, which is going to focus on convergence of data types on a single database, simplifying the data architecture. So without wasting any time, I would like to pass the microphone to Pani and he could start the presentation. So Pani, here you are.
Thanks, Alvo. Thanks for that introduction. Hi, guys. My name is Phani Turlapati. Elno did give a brief introduction about myself, but let me just reiterate that I've been at Oracle for about 8.5 years now. All these 5 years of those, I was a cloud solution engineer, cloud solution architect. The various titles and roles, but the point is that I was helping customers sort of move away, move their solutions into an Oracle database solutions. I was doing a lot of POCs, a lot of demos. I was building a lot of demos for our customers. So all sorts of stuff. Prior to that, I was a Java developer for about 4 or 5 years. I was developing applications. I worked, as Eleanor mentioned, I did work for a company called CNSI and Cognizant, and I did build real-time production systems for various organizations while I was at Cognizant and CNSI. Alnur had reached out to me about 2 or 3 weeks back, where he kind of said that he liked a blog that I had written about JSON Relational Duality. I have the blog up for you guys to see. This is where I kind of talk about how database natively speaks the developer language, which is basically JSON at this point of time. And now, before I get into the topic at hand, and basically talk about JSON Relational Duality, what I want to essentially talk about is what data convergence, right? Or simplifying the entire data architecture altogether. I want to go back in time. A few decades ago, organizations, especially large organizations across the globe, have designed applications using these purpose-built database systems. Now, it was a time when one single database could not do it all. You had all these different new business cases, and they were generating all sorts of newer sorts of data types were being generated. So at that point of time, it kind of made architectural sense to use the purpose-built databases because it could solve the current challenges, right? Now, as the enterprise essentially scaled up, these multi-database architectures, even though they solve that particular problem, kind of created a separate set of challenges. Some of them being data silos, generating, siloing the data, fragmenting the data. There's all these operational overheads that you get with maintaining all these different data types. There's all these ETL processes you need to do to move data from point A to point B to point C to actually extract meaningful insights out of the data that you essentially have. And think about all those different API access and data access mechanisms that you have to employ with each of these databases. Eventually, what it does is it basically increases cost. It becomes extremely difficult to govern these databases. There's going to be extreme amount of data redundancy. You're moving data, you're replicating data. Data security is going to become challenged, eventually leading to data lineage and data provenance fragmentation. So, and this is not something that it's not something that I am saying, or it's not something that it's not something that I'm essentially saying. It's been documented by various popular journals. Everybody's kind of agrees to a fact that multiple database systems does lead to all these problems, right? Now, we at Oracle, at Oracle, the approach with Oracle database, the approach has been entirely different, right? So Oracle did not say, oh, let's just build 10 different data types to solve all these different problems. Instead, what Oracle essentially did was that they started converging all these and natively processing these different data types within the Oracle database itself. So Oracle database essentially can handle graph data, spatial data, binary data, vector data, all these different data types natively within the Oracle database, including JSON. In fact, I just recently read a post on LinkedIn that kind of talks about how beautifully Oracle actually handles the JSON data type and the in an O of one way. So it's actually really interesting. I don't know if I get a chance, I'll probably post that link somewhere. But the point is that, since so Oracle's path has been to converge all these different data types into a single database. So your data governance becomes easier, managing the databases become easy, your security models become easy. You reduce your amount of effort in ETLing data from point A to point B to point C and all this essentially leads to actually extracting meaningful insights pretty much real time at this point, because now you're not juggling between databases. You have your data readily available in any kind of format, and all you have to execute is a SQL query on top of it to get into those insights. Now, one of the things that I want to talk about today is JSON relational duality, right? So that is the topic at hand. In fact, that's the thing that I really want to talk about. Now, JSON relational duality is very interesting, right? So what we did with JSON relational duality was, JSON, as everybody knows, is the normal way of interacting with interacting with various applications, right? That's the mechanism that you help integrating all these different systems, for that matter. So an Oracle database natively handles this particular data type. So what essentially does JSON relational duality mean, right? So what you can do is you can build JSON views on top of your relational tables, right? So say, for example, you have something like this, where you have an ID, your name, an address, street, zip, all in this JSON format. You can either treat it like a JSON file or as columns in the table. And it's a win-win for everybody, right? So developers can extract that particular JSON, move it across, process it by other systems, subsystems, and so forth, right? Or if you have DBAs, analysts, anybody who's analyzing those particular data, they can run their simple SQL queries. So as I said, what it essentially does is it unifies two different data types. You have your standard SQL, relational tables, and you have your JSON data type, which is a bit of a non-structured data type, or a semi-structured data type. Now they can be integrated into one single database, and you don't have to juggle between a NoSQL database and relational database anymore. It's all within one single place, and as I said, it reduces your data governance challenges. It increases. It actually builds a unified security model. It helps you with your data lineage and provenance fragmentation, and because it's all through one single database, you don't have to worry about how do I access the data, because it's all through the SQL. It's all accessible via SQL developers or whatever application that you essentially have that you use, right? So that's essentially what it does, right? So let's actually see, and I'd like to show a quick demo as well, and how this essentially works. But before I get to the demo, let me just tell you how the setup essentially looks like, right? So what I did was I said, okay, what's a relevant use case here, right? So what's where can this actually be used? So I thought about it and said, okay, let's just think about smart meters. Smart meters are it's generating a lot of IoT data. It's IoT data, and traditionally it's been of a JSON format. So I said, okay, let's just use smart meters as a way to showcase the capability, right? So what I did was I created a user. I granted all the roles that it essentially needed. What I did was I created three tables. One was the utility company table. So there are a bunch of utility companies. Then I generated a table called as electric smart meter table that basically consists of smart meter information, right? And then of course, the recordings, the readings, right? So since the data has been continuously generated, I actually captured that in a separate table, right? Now, the coolest part here is actually to develop a JSON relational duality view on top of these tables, right? So for that, let's actually switch to my other screen. And let me just walk you through here. So what I essentially do is I create a view, and I say I'm going to select a JSON type from two tables, which is one is electric smart meter table and the electric company utility table, and I'm going to join these two tables and generate a JSON file out of this, right? Similarly, because for each meter, I want to, since I'm capturing all the recordings, I want to generate another relational duality view. And what I essentially did was I created a Python app that would continuously push data into the database, right? So that's essentially acting as a testing mechanism for inputting all the data in, and then eventually being able to showcase the entire process. What I also did was, Oracle database natively supports a low code development environment called Oracle Apex. So what I did is um, I actually built a desktop application, or sorry, web application using Oracle Apex to sort of show how this essentially works. Right? So let's actually walk through the SQL worksheet, right? So this is my, let's actually first look at the tables. As I mentioned here, the bunch of tables, there's an electric smart meter table, there's an electric utility company table, and then the smart meter reading table. So let me see if I can, let's open this up. Let's look at the data here. So what I did is I have three different companies, Power Grid, Southern Electric, and Metro Energy. Their company addresses, where they're located at, and so forth, right? And then you have the smart meters itself. Now, within the smart meter, again, you have, I've basically registered smart meter with each of these electric companies. So there's one meter that's associated with one particular company. Um, you could add more as well. Since it's a demo purpose, since it was only for demo, I kind of just built like three of them, registering with each of these each of these service providers, right? And then reading, of course, is the data that's being generated continuously, and each meter. So reading is associated with a meter ID. It records active energy, reactive energy, voltage, current, all sorts of any sort of factor that goes into the smart meter and electric smart meter table, right? Um, so actually, let me run the query as well, and you'll see what it actually looks like, right? So let's actually view this. Let's view this. So this is how it essentially looks like, right? So it's a JSON file. It's a nicely generated JSON file. So you have the company name, the company address, and all the meters that get associated. In this case, since I only registered one meter with this company, you're only seeing one meter. But if there are multiple meters registered to their company, all that essentially pops up into the system, right? Similarly, when you run the electric smart meter reads duality view, let's actually show this. So for one of the meters, you can see that. So you have the meter ID, the installation date, and all the readings associated with that meter. So this as you see, there are multiple readings that are associated with this particular meter. This and all the data that goes into that particular meter. So this is all the data that's essentially within that particular meter, right? And then so this essentially what it does is it allows you to now move this data across multiple systems. Now it's in a format that is user friendly, that is that all the developers like to use. So you can easily translate and transmit this data across multiple systems and multiple subsystems, and you can build your analytics view and all sorts of stuff, right? So for our purposes, what I essentially did was for this particular demo purpose, or as I mentioned before, Oracle allows you to build applications using something called as Oracle Apex. Now, Oracle Apex is a really cool low-code environment that allows you to build a very intuitive UI to build those applications, right? So now this is something that we does come natively with Oracle database. It's just few steps of installation, and then you can pretty much run this application. And I believe there's obviously the cloud version of it available as well. There's so you can even use that as well. The point is, it's pretty straightforward. All you essentially have to do is build a few screens. So in my case, I have a home screen, which actually correlates to this, right? Let me see. So this is my login screen. This is my home screen. So if you look at this, this is essentially what it is. This is the table that's getting all the information. So this is all the details of all the power company, where they're located, and we saw this essentially in the app as well, in the tables as well, right? So this is that particular screen. It's pretty straightforward, pretty simple, and it looks at all the sorry, it looks at all the details, and then I actually ended up joining this with the electric smart meter data table as well, so that I can actually link it. So if you see, I've registered, as I said before, there's one meter registered with each of these companies, so I can actually look at that particular meter, and now I can actually look at the analytics within that meter. So as you see, I have all this data that's available. Since all the energy that's being generated, all the reactive energy, voltages, and I can actually look at all that data, correlate it, see what the temperature was, build a nice graphs. I don't know why this isn't being displayed, but there's actually a entire chart on this as well. The point is, all this is very simple to build, and if you actually go back to this particular page, you can actually, oh my god, just give me a second. Some sort of error that's happening here. Okay, let's see. Yeah, so you can see it's pretty simple to put a chart in. So I have the active energy temperature. That's this line, the green line on top of the chart. Similarly, I have reactive energy, similar sort of chart coming from a table, and then again the temperature line that sort of talks about how the energy uh, varies with the temperature itself. The point is, again, this is all generated data, but the point is, all this can be easily done within this particular low code environment. And all you essentially have to do is, all you have essentially have to understand and know is what are the tables that you're essentially you want the data to come out from. So that's the demo. And that's the essential demo, and this is what this entire blog essentially talks about, right? It kind of talks about how within a single database I can build both JSON views, JSON relational duality views, so that I can get the data in form of a JSON file, or I can actually look at the data in form of relational tables. So I can execute queries against that table, or I can take that data and process it in other subsystems as well as JSON files, right? So that's my demo. That's my talk. The overarching point here that I want to make is that you want to simplify your data architecture. You don't want to deal with multiple databases, because as more and more databases grow, data silos become data becomes siloed. There's fragmentation of data. You have to think about moving all that data from point A to point B to actually being able to extract meaningful insights, right? So you want to get away from all those challenges and actually simplify the entire data architecture so that you can get to your insights faster, be more real time, produce applications that are more real time and more user friendly and more more reactive in nature, more active and more reactive in nature, right? So that's why this capability is really important. Back to you, Omar.
Yes, Yeah, thanks, Phani. A lot. Thanks a lot for really interesting and I really like this how this it's universal that everyone can use it and meet their needs. We could maybe move on to questions. Maybe we could start from Atakan if he has any questions.
Sure.
Yeah, yeah, it was really interesting. So I wanted to ask about like, okay, we create these views, right? So
Mhm.
there was also, are they like the change when I do a modification, are they changed on the fly, or is it like something like the snowflake where I need to, it will start applying for the things that's gonna come after, or like, I need to go by
Are you talking
reindexing
about the application page or
the,
the sorry, which
no,
one?
this on this like on the duality, so this duality JSON, like we had this view, right? Like on the
Uh,
database side.
yes. So on the database side, everything is going to be real time, right? So because you're inputting the data into a duality view, it's not like it's capturing the data first. It's basically just real time. So as soon as the data flows in, it starts putting the data into the right tables. So you can just dump a JSON file into the database, and it automatically figures out. Because as you can see from my query here, if you actually look at the query here, you'll realize that I can actually update or insert the data as well. So it's not just selecting the data out of the database. I can actually update and insert on real time. So as soon as it finds a JSON file that's similar in structure, it's automatically going to figure out, and it's going to figure out and say, oh, I've got all this data that has just come in, which has my timestamp, reactive energy, and all that stuff. It figures out I need to put it into the table. I need to put it into a smart meter reading table, and then I need to associate that with the smart meter table itself. So these two things it's going to figure out, and it's going to start putting the data into the database itself, and it's all real time. There's no there's no ETL process essentially here.
Sure. Yep. Got it. Thank you.
Absolutely.
Pani, I had one question. I
Yes.
see that this data is coming from IoT devices, right? Smart meters.
Yes.
I want to ask that, like, is there any other use cases that like it's suitable or it's mostly used for like IoT data types? Like, what you can say about those? For
Well,
example, like it can't be used on like microservices, let's say.
yeah. Exactly. I mean, it's pretty much so JSON, as I mentioned in my blog as well, is a universal language now, right? I mean, that's how the applications interact with each other. So anywhere where there is a JSON that's being generated, and you need to store that JSON. Traditionally, you have to store that into in these NoSQL unstructured semi-structured databases, right? No, you don't have to do that anymore. You can pretty much store it in Oracle database and then natively generate that JSON out of the database, right? So my point is like wherever applications that require JSON type, process the JSON type, JSON data types, it's Oracle database can be the backend of that. You don't have to now think about, I have this data that's coming in, like for example, mouse clicks, right? Mouse click data is all JSON data, right? So when all that data is being generated, now you don't have to store that into a NoSQL sort of a database. You can directly store that into Oracle database and then build tables on top, of that, so that now you can actually analyze your data much faster. So any use case where there is tremendous amount of data being generated, you can just dump all that into an Oracle database, and you can and nicely generate analytics on top of that from your relational tables. Does that make sense, Elmer? Or you want me to clarify
Yeah,
further?
sure, of course. Yeah. And also, let's say if there is need, like, let's say if I have some data and I would like to migrate to Oracle, right, for these
Mhm.
purposes, how painful is that for developers like doing this?
Yeah. So when it comes to migration, migrating from different data types is obviously going to be a challenge, because then you have to basically, uh, no. I mean, I'm not going to sugarcoat it and say it's going to be super easy, because it's generally not. There's a lot of steps that go into figuring out what the data is, what data types it has, and all that stuff, and then figure out which columns it needs to go into. So you need to do your due diligence and then figure out a path to moving the data across. Now, if it's only JSON files and it's only JSON data, then it's easy to just dump all the data out and dump it into the Oracle database. In fact, if it's coming from a MongoDB, Oracle has this capability called as MongoDB APIs. So which kind of can natively read MongoDB data, and then it mimics the way it gets emitted. I don't have the full insights of how that essentially works, but that's something that allows you to quickly migrate from MongoDB to Oracle database, a MongoDB API. That's a native capability. Similarly, we've built a database capability for I believe DynamoDB as well. I need to check on that. But my point is that migrations is going to be based on the use cases, right? So it all depends how quickly can somebody move over their data into the Oracle database. But if for any new application development, I mean, this can be a good starting point.
Yeah. All right. Thanks a lot. That was it for my questions. And yeah, guys, that was the end of DevStandup episode 21. And today our guest speaker was Phani. I would like to thank him for his great presentation and insights about the topic. And every week we feature one IT specialist from the industry to share their experience with everyone in the world. And if you would like to be our next guest speaker or know someone who would like to be, please contact us. The link under the description below of this video. And we would like to invite you to our DevStandup session. Apart from that, have a nice day, guys, and see you in our next DevStandup. Bye-bye.
Thanks, everyone.